Hello friends, welcome back to BitSize Python. My name is Nijat. Hope you're having fun with data structures and algorithms. If you haven't already, subscribe to this channel as we tackle more LeetCode questions. Today we're going to tackle LeetCode question number 5, which is the longest palindromic substring. So the problem is we're given a string S and we're going to return the longest palindromic substring in S. A palindrome is a string that reads same backwards or forwards. For example, the word race car, if you read it forward and backward, it's the same. So that's what a palindrome is. And then the given example here is S is equal to BA, BAD, and then the output that we should get is BAB because that's the longest palindrome that reads and forward the same way. The second example is CBBD. And then the longest output or the palindrome here is BB because that's the longest that reads backward and forward the same way. And then here are the constraints. And then there are some recommended approaches for this. The first approach is called dynamic programming approach, and second one is called expanding around the center of the potential palindromic string. Both of these have a time complexity of O n squared. And then the second approach, the expanding around the center potential palindromic string approach is actually more efficient because it saves more space compared to the dynamic programming approach. Because of this reason, we're going to focus more on the second approach. It's called the expanding around the center approach. And then I have provided the logic here step by step, and we're going to build that function. So now let's build a function. The definition is given, it's called longest palindrome, and then we're given the string. So first of all, we're going to create a helper function just to make the process more streamlined. Helper function, let's call it a definition, let's call it expand around center. So we're expanding around center, we're going to give it a left pointer and then right pointer. And the left pointer is pointing towards the left side of the string and right is pointing to the right side of the string. So we will loop through while the left side is greater than or equal to 0. So, and that's the first element of the string. And the right side is less than the length of the string. And the left side of the string is equal to the right side of the string. If those three conditions are met, meaning that the first two conditions will make sure that we're actually within the boundaries of the string, and then the last condition makes sure that it's actually a palindrome. If that's the case, we're going to expand it to the left side and then right side. So the left pointer is going to be reduced by 1, and it's going to move to the left more, and then the right side is going to move to the right more by moving to the right. And then after the loop, we're going to return the string, the palindromic string. Return S left plus 1 all the way to the right side of the string. So we're done with the helper function, and this helper function is helping us to extract the palindromic string. Now we're ready to consider the different conditions or the different lengths of S. When S is empty, or just 1, then it means that if len S is empty or just 1, len S is less than 2, we're just going to return S because this means that the S is automatically a palindrome. If that's not the case, we need to loop through the S index by index and then make sure to extract the longest palindrome within it. So how do we do this? In order to do this, let's first create a variable called longest. It's an empty string to hold what we are going to extract, and then this is what we're going to return at the end as well. So longest, and then we are ready to loop through the S. For I in range len S. So this is going to loop through the string S index by index. And then there are two cases we need to consider. The first case is the odd case scenario. odd case. In the odd case scenario, for example, if the string is odd length, ACA, we only have one center to expand from. In that case, we will create an odd palindrome, that's just called odd pal, and then expand around center. Because we only have one center, the left and then right pointers are all going to be the same. It's I. What if we have even cases? ACCA. In this case, we have two centers instead of one. So let's create an even pal. Use the expand around center, and then the left pointer is still I, but the right pointer is going to be I plus 1 because we have two centers now. We're just extracted the palindrome from these even and an odd cases, and then we need to now update the longest substring. The longest is going to be equal to max of the longest itself, and then the odd pal, and then even pal, and then the key is equal to len. So what this step is doing is that we're comparing the longest one, and then the odd one that we extracted, the even one that we extracted, and then we're going to compare them based on their length. Whichever one is the longest is going to be given to the longest one. And at the end, we're going to return this longest substring. So that's it for the whole function. Let's just quickly summarize. So we first created a helper function to extract the palindrome by using the expanding around center approach. And then we considered the empty and then or one length cases. And then all the other cases will be considered using this for loop. And then that's it. Now that we're done writing the functions, let's quickly run the function. And then we're now ready to test the functions here with these test cases. And then I've written some test cases here. On the right side, there are the expected outputs. Let's run this. So they, as we can see, they successfully extracted the longest substrings from the strings that are given. Great. So from this, the key insight that we can gain is expanding around center reduces the need for additional space and then efficiently locates the palindromes. However, the time complexity remains O of n squared. So there will be other more efficient ways to solve this problem. However, if you want me to delve more into it, let me know in the comment section. I will do that. Hope you had fun solving this problem with me. And if you haven't already, please subscribe to this channel as we tackle more LeetCode questions. And I will see you in the next video when I tackle LeetCode question number 6.